Welcome to the Class Exam 1 Review and Practice Problems session. The instructors have put together this video for you so that you can go through it at your pace as quickly or as slowly as you would like, and you are free to review it as many times as you'd like to help you to prepare for the exam. There is an exam review sheet on Blackboard. There is a section entitled Exam Review Sheets, and so you could click on there and you can find that exam review sheet. It is very thorough. It will list exactly what is going to be on the exam, how you should prepare, what topics are expected, as well as all of the formulas that will be given to you for the math type problems on the exam. Here's the format of the exam, and this is repeated on the exam review sheet, but this is just as a review for you. The exam will be 34 multiple choice questions, and each one of those is worth 3 points each. That is going to be the same format for all three of our exams. They'll all be 34 multiple choice questions. Now, this particular exam will be 11 math or computational type questions. I'm going to be going through each one of those calculation problem types today with you on this video so that you are familiar with them. And then there are additional practice problems available, many practice problems for each one of these computational problems available on Blackboard as well. 23 of the questions will be conceptual in nature, either definitions, concepts, principles, ideas. I'll try to give you some ideas today about where you might find some of those questions. Keep in mind that, well, on the math and on the conceptual questions, the answer choices are not listed to limited to 5 choices. There will be some that have more than 5 choices available for you, but you will, in each of them, you will have to pick the one answer that you feel is best. Because there's 34 questions, 3 points each, the maximum exam score is 102 points. This is the same as you getting 2 bonus points on every single exam. So, regardless of whatever your score ends up being on the exam, your score is equivalent to having 2 bonus points added because we're really, it's graded on a scale of 100, and you can possibly get greater than 100 on this exam. So the exam will be administered through Blackboard. There will be a link available on Blackboard once the exam begins. Do not click on the link until you are in the CASA Testing Center to actually take the exam. We have some safeguards in place related to that, but it'll just be easier on all of us if you do not click on that link until you are actually in the testing center. The exam, you will be allowed 110 minutes once you click on the link to begin and finish the exam. It needs to be finished in one full session, and it is completed at the CASA Testing Center. It is a closed book, closed note exam. You may have one of the approved calculators, which I have shown you on the slide there, the same calculators that are used in the stat class and the statistics class. All the formulas that you need on the exam will be given to you, and on the review sheet are all the screenshots that you will see for those. Our review session today is similar to the exam in that next to each one of the questions that you'll be given, the computational questions, a picture of the formula that you need to solve that problem will be posted next to the question. So you won't even have to go search for them. We'll post the formulas right next to the questions, right where they're needed. You can also use the on-screen calculator on the CASA computers if you'd like. And the exam location is the CASA Testing Center. And you should have, by this point, already signed up for your testing slot with the CASA Testing Center. If you have not yet made an appointment with CASA, you should go to the CASA website, which is shown here, or you can go directly to their office and ask how to sign up for an appointment with CASA to be able to take your exam. Now, our exams this semester are spread over several days to be able to accommodate the large number of students that will be taking the exam. There are enough time slots available during those days to accommodate all of the students in our class. However, there are not enough time slots for all of you to be able to take your exam, for instance, on the last day that is available. So at this point, if you have not yet made an appointment with CASA, then you will just be limited to the time slots that they have remaining, and you'll have to choose one of those. Those dates have been in the class schedule since the beginning of the semester, and we have maintain those dates the entire time. So you've had those available, and we mentioned at the beginning of the course that those are dates that you should plan to have flexibility or clear out time to be able to take your exam. So make your appointment with CASA if you haven't already done so. The next thing that I'm going to ask you to do is to print your appointment confirmation. I have had several students in the past that have missed their exam because they either have the wrong date or the wrong time written down for their confirmation. And so you need to go to the CASA website, make sure that you know what day and what time. Don't just trust that you signed up for the correct one. Make sure that CASA has a confirmation that you have signed up for that particular day and that particular time. You do not want to show up at CASA and have them turn you away because they don't have you on their list. The sections of the book and the course content that is being tested is listed on the exam review sheet. We'll go through that in a few minutes, and so you should have those available. Any content that you need from Blackboard, so that would be class slides, PowerPoint slides, practice problems, any other resources that are on Blackboard that you would like available offline while you study for the exam, you need to download those now so that you have those available. Download them onto your computer, onto a USB drive. The Blackboard content will be removed and disabled prior to and during the exam testing sessions. This is to provide some consistency and some equity among the testing conditions for all of the different students. It also gives us a little bit of control over academic honesty issues. Additionally, the assistants and instructors will not be available to answer questions once the exam has begun. This is one way that we're able to establish some equity among all of the different students so that students, for instance, taking the exam at a later date don't necessarily have more access to assistants and instructors than students taking the exam earlier. So if you have questions about your studying, about the material, about practice problems, or would like some help with that, make sure that you see the assistants or your instructor sometime prior to when the exam sessions begin. Also, because most of Blackboard functionality will be disabled during that exam testing session, make sure that you can log into MyOMLab by going directly to the Pearson website. So I've provided that link here, and I'll have a slide coming up in a minute that will give you some instructions about how to log on there. You want to practice logging on directly through the MyOMLab site now, so that you can confidently do that during the testing session. Now, on your scheduled exam day, you should arrive, we are recommending that you arrive at the University of Houston at least 1 hour early. Now, my suggestion personally to you is that you arrive several hours early, and this is to avoid traffic issues or unforeseen delays like a fender bender or a flat tire or car trouble. By leaving early enough to get to the University of Houston at least 1 hour or several hours early, then you'll be able to make contingency plans if some of these things happen, get alternative transportation, and be able to still make it to your CASA appointment. You should be here in time so that you can check into CASA 20 minutes prior to your exam time. That is their preferred method, is checking into CASA 20 minutes prior to your exam time. You will need a photo ID card. The UH student ID is the preferred ID card that is required for your check-in. And if you haven't taken an exam at CASA before, I'll just let you know that CASA is very strict on when exams begin, and so they will not allow or they will not permit admission to the exam if you are late. So you definitely want to be early to that exam. Students in the past have been just a few minutes late to their exam session, and because CASA stacks these exams back to back to back, make sure that they have testing seats available for all the students, they do not permit late admission to an exam session. And then once you're in the exam, you may click on the exam within Blackboard and you'll be allowed to take the exam at that point. Please note that exam grades will be posted on Blackboard only after all students have taken the exam. So once you complete the exam, you'll click that you save all of your answers. It will submit your exam at that point, but your grade will not be available until all the students have taken the exam, which will probably be sometime the following week. These are the instructions for logging directly into MyOMLab. Make sure that you are able to do this if you would like to use the MyOMLab resources prior to our testing sessions. So where can you find the content for the exam? Where can you find potential exam questions? So I'll try to give you some guidance here. Your first resource is going to be the exam review sheet. So on the exam review sheet, if you'll skip over to the second page of the review sheet, it lists out all of the topics that are tested on the exam. So it will give the section of the textbook, the title of the section of the textbook that is covered. It also will list sections of the textbook that are not covered on the exam so that you can avoid studying those sections. It will also tell you, we've been mentioning during the class, that some of the class material is not listed in the textbook. It's material that the professors here in the supply chain management program at Bauer are familiar with. It's supply chain topics that real companies today are dealing with that just isn't covered in the textbook, and so we cover those in class to make sure that you have coverage of those. Any of those are listed in this section as well. So I guess the first thing you should look at is what types of questions will be on the exam. Now you already know there will be conceptual questions and computational questions. So let's look at each of those. First, the computational or the math type questions. If there is a math-based question that is on the exam, you can be assured that your professor has completed at least one example of each of those types of questions during class. Today, during this review, I will also be going through additional examples of each of these so that you'll have them. In the practice problems section of Blackboard, there are lots of practice examples, and these are listed as questions that are structured very similarly to what you'll see on the exam, as well as solutions for all of those so that you have the solutions as well. Then, of course, you are welcome to make up your own potential computational math questions, and you could use these to quiz friends, for instance, in a study group, just by changing the wording and the numbers of some of the problems that you see in the practice problems or the problems that you see me complete today in this video. So what sorts of questions will be asked as a conceptual question? There's typically a few different types of questions, categories of questions that fit here. One is definitions of terms. So anytime that you see a definition of a term that is posted on one of the PowerPoint slides that we presented during class, where it lists the term and then has a colon or something similar to that and then defines that term, that is definitely a possibility for an exam question. There's a couple of different ways that we will typically word those questions. One would be the best definition for whatever that term is, and then it would list several different definitions, and you would have to pick the best definition. Another way of structuring that question would be the term that is most closely associated with, and then it would list the definition is, and then it would list several different terms. You would have to pick the term that matches to that definition. There's also several lists of items that you'll see in the PowerPoint slides. So as we're going through the PowerPoints, as you go back through your notes, the PowerPoint slides that we presented in class, many of the slides will have a category of knowledge about supply chain, and then it will list several different terms or several different principles or several different characteristics about that particular term, and those will be listed as bullet points underneath the main item. Those are lists of items, and these are also very easy for us to test. This is very similar to many of your classes. Many of your professors will do the same thing. A couple of ways we will answer this is by, or ask these type questions would be, this particular supply chain management principle includes all of the following characteristics except, and then we would list all of the different characteristics, but then we would add in one that really isn't a characteristic of that. And then another way of wording it would be to say which one of the following is included within this particular principle, where we would list the main idea, and then we would list one of the things that applies to that along with several detractors, and you would have to pick the correct one. There's also just supply chain management organization of ideas. One of the major ones that we talk about all the way through the course is the idea that we think of supply chain as plan, buy, make, and deliver, and then return. And so those sorts of organization of ideas, how different principles within supply chain are connected to one another, how managers deal with supply chain management ideas or concepts, or how they make decisions. Those are ideas that could be used as a conceptual question as well. Those are things that were covered during our class sessions together, and most likely your instructor gave some sort of an example about how that supply chain management works during class that would have explained those items. So how to study for these types of questions that are going to be on the exam. We need to let you know, exam questions will come directly from your class notes, directly from the PowerPoint slides. When we take exam questions from the PowerPoint slides, we will not change the wording that is used on the PowerPoint slide. We don't want to confuse you. We want to be able to test whether or not you understand those concepts. Those are most likely going to be definitions of terms or particular lists of items. There will be some exam questions that come directly from things that your professor has discussed with you in the class, giving you examples of different things, talking with you about how supply chain management works and how supply chain managers make decisions. And those exam questions will come directly from the class discussions. There are also exam questions for the computational or math questions that come directly from the practice problems. So those are things that you should certainly spend most of your time studying. Now, the textbook that we use for this class is used to support the material for the class. But of course, the textbook does not include all the things that we talk about in the class. And there's a lot that's in the textbook that we don't talk about in class. You have already been tested on your general familiarity with the textbook by using the quizzes and the GLMs. We will not be pulling obscure information out of the textbook to create exam questions. So you do not need to memorize textbook material to do well on the exam. If you study directly from your class notes, the notes that you've written down from what the instructor has been talking with you about during class, and completed practice problems, then you will be well prepared to be able to perform very well on this exam. So how about some advice for studying for the exams? And this advice comes from suggestions from many students over the past several semesters who have given us ideas about how they have performed well in the class. Now, I guess, tongue-in-cheek, the first bullet point here, what is the worst way to study for the exam? Now, this has been proven in research on college students that the absolute worst way to study for an exam is to sit down with your notes and read them over and over and over and over and over, hoping that just by reading your notes, you will somehow be able to remember them when you come in on the exam. That has been shown scientifically to be the worst way to study for an exam. It does not help students to recall information, as well as other methods that are a lot more powerful. So what are some of the best ways to study for an exam? So there's several here, and these techniques have also been proven in research on college students to help students perform very well on exams. So one is to rewrite your notes, but not just copying your notes. Don't just take your notes and copy them, or take the PowerPoints and write the words out that's already printed out on the page. Take a look at your notes and then rewrite your notes, but rewrite it in your own words and try to explain it as if you were explaining it to someone else. Now that takes a little bit more effort, but by doing that, you're going to actually encode that information into your brain, making it much more likely that you'll be able to recall it. Another thing you can do, which many of our students do, is to create a topic outline of all your notes. This will give you good main ideas about the material, how the material fits together, the different parts of the material that interact with one another. This will really help you as well on those computational questions where we're looking for supply chain management relationships and concept type questions. By creating a course outline or a topic outline, it's going to really help you to understand how those topics mesh together. You can also create your own sample exam questions. Now, on the previous slide, as I was talking with you, I told you what types of questions are going to be on the exam, gave you examples of each of those exam problem types, and you could actually go through your notes, go through the PowerPoint slides, and you could actually create for each exam, for this exam and for the other exams, you could create dozens of different exam questions that could potentially come from those slides. And chances are you're going to have a lot of those exam questions that are actually on the exam. And so this is a great way you can use those sample exam questions within a study group. Now, research has also shown that students that join a study group tend to do better on exams than students who don't. Now, I realize that there are personality-wise, there are some students who prefer to study by themselves, but I will encourage all students for part of your study time to join a study group. And here's kind of how that would work. You would get together with a group of fellow students taking the class. You would print out all of the practice problems without the answers that we have provided on Blackboard, then cut those into strips so that there's just one practice problem on each page. Then for instance, assign certain lectures to each one of the study group members where they would create exam questions based upon that particular lecture. You'd bring all of those problems and questions together, one question on each page, put them in the middle of the table, shuffle them all up, pull out one question at random, and then try to figure out the answer to that question as a group. By pulling out the questions at random, you will actually mimic the way that the exam will appear to you, because the exam will be giving you questions in a random order as well. So you'll be able to mimic what it would be like on the exam, with exam questions that are likely to be actually on the exam. And of course, it's our intention that you would be able to practice math problems using the practice problems. Do not look at the solutions. Really try to solve those math problems using only the formulas that are given on the exam review sheet, and practice those math problems. Practice them and keep practicing them until you feel very confident with those math problems. It's our intention as instructors and with the exam that those math problems should be very easy to you. You should have practiced them enough to where that should be sort of the sure thing on the exam, the thing that you feel very confident about that you would be able to get correct, because they are definitely going to be on the exam, and the format that they're going to be there has already been given to you. Now, there are some things that you will probably want to be memorizing, for instance, definitions of terms or lists of particular items. And to do that, you're going to want to use an effective memory technique. Keep in mind, just reading the lists or reading your notes over and over again is not an effective technique for memorization. But there are several different techniques that are available. So one is to create an acronym. Now, many of you have done this before, where you have created an acronym for the terms that are in a list. And so you could do this, creating your own acronym. There are also several very powerful memory systems And the names of some of them, some of my favorites are the link and story methods, the number or rhyme mnemonic methods, or the Roman room system. You can certainly look up those methods on Wikipedia, and Wikipedia will tell you how to use those things, sort of teach you how to use those things. There's also a website called www.mindtools.com, and they provide guidance, and they provide little online courses for each one of these techniques. Learning these techniques will help you in all of your classes. So there is no one at Bauer who gets any sort of kickback or any sort of compensation from www.mindtools.com. It's just that is a website that has been around for quite a while and does a good job of teaching these memory techniques. And it might be something that is that's interesting to many of you to go out and try to use. And as I mentioned, using these memory techniques should help you not only in this class, but will also help you in all of your other classes that you take at Bauer. So here's how it works. You go to www.mindtools.com. You will click on the Toolkit link, which will pull down this pull-down menu of categories. You will then click on the Learning Skills category. Then you will click on the Memory Techniques link. And finally, you will click on the article that you are interested in. I mentioned to you that I like the number and rhyme mnemonic technique. I like the Roman room system, and I like the link and story methods, although there are several different articles there. I have contacted www.mindtools.com, and they confirmed to me that the first 3 articles that you open are free. After that, you can sign up for a subscription with their website. They offer the first month for $1, and there are thousands of different articles that are available here to help you with your studying and help you be able to absorb classroom material better. And if you do subscribe, they do offer a 25% student discount. You can either email them for that discount, or they mentioned to me that if you just sign up with a .edu email address, they will give you the discount automatically. Now, you do not have to subscribe to their website. Like I said, the first 3 articles are free. I've given you 3 suggestions of ones that I would look at first. Then, of course, their first month is very inexpensive, just $1. So you would have access to quite a few of those articles and resources if you wanted more than that. Of course, any of these techniques you could also look up on Wikipedia, or just do a Google search and learn about them there as well. You can definitely just use this website as a resource to find topic titles that you could then search for on the internet. So what specific topics will be covered on the exam? Now, I mentioned to you that all of the topics are listed in detail on the exam review sheet, but we did cover some portions of Chapter 1, Chapter 2, Chapter 9, and Chapter 10 that will be covered on the exam. Now, not all of those chapters are going to be covered on the exam, just certain parts of them, and those are all listed on the exam review sheet. But in general, we talked about supply chain management overview, just an overview of what supply chain management is and how it's structured. We talked about operations and supply chain strategy and that strategic planning executive role that supply chain managers have. We then talked a few classes about forecasting and forecast accuracy and strategic management using forecasts. And then finally, we talked about sales and operations planning or aggregate planning, that we begin to look at inventory and begin to look at how we keep products and where we should keep products in a supply chain to be able to meet specific customer needs. All right, let's do some math type problems. So I'm going to go through each one of the different math or computational problems that you're going to be required to do for the exam. My suggestion to you to be able to use this video is to only use your exam review sheet to do these problems along with me. So the exam review sheet will have the formulas printed out, and you'll have those available. And so my suggestion is that periodically you pause this video. I'll make sure that I give clear instructions as we're going through the video to pause the video, try the problem on your own, and then I will show you the solution to that problem. And then you'll be able, of course, you'll have the solutions as well in your class notes, but then that way you can identify where you still need to study or where you may be need to have a little bit more attention or a little more practice. So here's our first problem type, and that is calculating a value index. We did have a formula for this. I will show you the formula on our next slide as we begin setting up the problem. But if you recall, the value index is taking the sum of us multiplying an importance value by a performance value. So we're going to have to list out some importance values for some items as well as some performance values for some items and multiply those two together. So here's our first example. The Tree River Fire Department is trying to decide which of 3 pumper trucks to purchase. All 3 trucks, each of them priced at $450,000. The department is concerned about water capacity, how many cross lays or fire attack hoses can be pre-connected, and the seating capacity of the cab. So below in the matrix that you see below are all of the performance numbers for each of those dimensions for each of the 3 trucks. So you can see, for instance, that truck A has a certain water capacity, pre-connects, and seating of the cab. And the numbers there refer to their performance value. And if you can tell that this is on a scale of 1 to 10. Now, the chief feels that the following weights should be used. And remember, higher weights are more important. A 5 for water capacity, 3 for number of pre-connects, and 4 for the firefighter seating. So you can see there that water capacity is the most important, seating is the second, and pre-connects is the third most important of those 3. And then we are asked to create a value analysis. So in problems like this, it's probably useful for you to set up the problem in a matrix that is very similar to the way we saw it in class. So for that, what we would have is each of the different characteristics, for in our case, water capacity, pre-connects, and firefighter seating on the left, have the importance value in a column, and then have the performance value for each of the 3 trucks listed, and then we'll be able to calculate the value for each one of those independently. So let me show you how we would set up this problem. So it will probably be useful for you to set up the matrix in this format, which is very similar to the way we did it in class. And of course, the value formula that you will be given on the exam is shown here. This is exactly the same picture file that will be displayed next to these type of problems on the exam. Now, our next task is going to be to calculate the value using this formula for each of the 3 trucks. So currently we've got the importance value, we have the performance value for each of the 3 trucks, and now we need to calculate the value. To calculate the value, you just multiply that importance column by the performance value for each of the 3 trucks to get a value for each of the 3 trucks, and to get the total overall value index, we just add the values of for each one of those dimensions that we see for each one of the 3 trucks. So what I'd like for you to do now is I'd like you to pause this video. I'd like you to take your work and try to solve this on your own, and then we'll take a look at the solution. So here's the solution. Let's walk through a few of these numbers and make sure that you know where they came from. So the value for truck A as it relates to water capacity, so that's the number 35 that you see in the matrix there, that number 35. That number 35 came from the importance value, 5, multiplied by truck A's performance for water capacity, which is a 7. So 5 times 7 is 35. How about let's look at truck B for performance for pre-connects. So truck B for pre-connects, let's find its value. So the importance for pre-connects is a 3. The performance for truck 3 or truck B is an 8. So 8 times 3 is 24. That's where the 24 comes from. Same thing for instance, truck A for firefighter seating. The importance is a 4. The performance is a 7. 4 times 7 is 28. We then simply add up the values for each of those trucks. So for truck A, it's 35 plus 30 plus 28, which gives us 93. For truck B, it's 40 plus 24 plus 24, which is 88, and so forth. And then when we are choosing the pumper, one of the questions that you would be asked on the exam is which of those trucks would we prefer, or which one creates the most value? And that would be, in this case, truck A. So anytime you have a higher value index, that is a more preferred option. Anytime performance is higher, it means it's performing better. Anytime that you see an importance value that is higher, that means it is more important. So higher value for truck A means that the highest value index for truck A means that that is the preferred option in this problem. All right, let's do some forecasting examples. Now, just as a reminder, the only forecasting methods that are going to be on the exam are the ones that I'm going to be showing you here in this presentation. They're the same ones that were shown to you in the classroom, and it's listed there on your exam review sheet. Now, in the textbook, there are several other methods for forecasting, as well as more detailed representations of some of the methods that we're covering here, but those you should not study for the exam. You should definitely just focus on the forecasting methods that we're showing here, because these are the ones that are going to be on the exam. So first we'll do some basic forecasting using some moving averages. So here's the example. The Elm Lake Fire Department wants to forecast the demand for structure fires. The last 5 years of data are shown below. And so it shows there year 1, 2, 3, 4, 5. So now remember, we're going to assume we are standing in year 5. The most recent demand was 13. In other words, in this year that we're in, year 5, there were 13 structure fires. We are trying to forecast how many structure fires should we plan for next year. So we're going to use 3 different forecasting methods: the naive forecast, a moving average forecast, and then the weighted moving average forecast. Now here's how the problem might appear on an exam. So in this case, what you'll be given is the problem statement, and you will be given some data, and you will also be given this screenshot of the formulas for forecasting. So everything you need is right here on this page. And of course, the problem here is asking, what is the naive forecast for year 6? So you're supposed to use the naive method of forecasting. So I would like for you to pause the video here, and I would like for you to work this problem on your own and find the naive forecast for year 6 given the demands that we're showing here in this slide. So to solve this problem, the formula that we need is the formula at the top of the little formula block that's shown on this slide. It's that the forecast for the next period is just the same as the demand for whatever our current period is. So in this case, we're standing in year 5. We're looking forward to year 6. And so our estimate using the naive forecast is that the demand for next year will be exactly the same as the demand for this year. So just 13. There's really no math to do there. Just copy down 13. So let's do this next example. Now this next example problem has exactly the same data, and we are still forecasting into year 6, but this time we would like to use the 4-year moving average forecast. So at this point, you've got the formulas, you've got the data. I would like for you to pause the video and see if you can solve this problem yourself. So the secret to solving problems like this is knowing what year you are standing in. So in this case, we are standing in year 5 and we are trying to forecast into year 6. And so we will take the 4 years, since it's a 4-year moving average, we're going to take the 4 years of most recent data and average them. So to create the average, you just add them together and divide by the number of numbers that you have. And so you see here that our forecast for year 6 is 12. Now, had we had a 5-year moving average, then we would have taken all 5 years and averaged those numbers together. This problem could also ask for what is the forecast for year 5. Now, if we're asking for a forecast for year 5, then that implies that we are actually standing in year 4. So we're in year 4, but we're forecasting for the next year out. And in that case, the 4-year moving average would be the average of 12, 16, 10, and 9, which are the most recent 4 data points if we're standing in year 4, and then that would be forecasted into year 5. We're trying to predict what year 5 looks like. But this particular problem was asking for the forecast for year 6, so that means we are standing in year 5, and we look at those 4 most recent data points, 13, 9, 10, and 16, add them up, divide by 4, and we get the forecast for year 6. All right, now let's use this same data, and this time we are being asked to calculate the weighted moving average forecast. So I'll ask you a couple of questions here. The first one is, you have the data here for the weighted moving average. Is this a valid weighted moving average that's listed here? That's my first question. And the answer is yes, it is. And the reason that it is because those 3 decimal values that you see inside of the parentheses there, when you add them up, they add up to 1. When you have a weighted moving average forecast, the sum of the weights, those 3 numbers, those 3 decimal numbers, must add up to 1. So again, in this case, we're standing in year 5. We are looking into year 6, trying to determine what year 6 will be. We are going to use the 3 most recent years of data to be able to make our prediction, and we're going to use the following weights, those 0.5, 0.3, and 0.2. You have the formulas here. Why don't you pause the video and you give it a try yourself, and then we'll come back and take a look at the answer. So if you'll recall, when we're doing weighted moving average, the first decimal value, that first decimal value weight that's listed in parentheses, will be applied to our most recent data point. So that's the 13. The second one, that 0.3, will be applied to the next most recent data point, which is year 4. So 0.3 times 9. And then 0.2 will be applied to the next most recent, which is the data for year 3, which is 10. So if we take 0.5 times 13 plus 0.3 times 9 plus 0.2 times 10, we get the answer to be 11.2. So 11.2 is our best estimate for year 6 then. Now, as you can see here, you may need to use some scrap paper, some scratch paper, in order to do some of the calculations by hand on paper. You can definitely request scrap paper or scratch paper from the CASA Testing Center. They will allow you to use that. Of course, you'll need to return that to them at the end of the testing session. Let's take a look at a couple more iterations of this. What if it was asking for the weighted moving average forecast, and let's say that we had the same 3 weights here, but in this case they were looking for the forecast for year 4 instead of the forecast for year 6. So if we're looking at the forecast for year 4, then that implies, for this example, that we're actually standing in year 3. So if we're currently in year 3, then year 4 and year 5 have not happened yet. We're standing in year 3, and we need to forecast for year 4. And so in that case, the most recent 3 data points would be 10, 16, and 12. We would take 0.5 times 10, 0.3 times 16, 0.2 times 12. Now, this problem could have been worded as a weighted moving average forecast for 4 numbers or for 5 numbers, and in those cases you would be given 4 or 5, depending on the case, 4 or 5 decimal values listed there. So because this is a 3-period weighted moving average, you're given 3 weights or 3 decimal values. If you were given or asked for a 4-period weighted moving average, you would be given 4 decimal values there. And if you were asked for a 5-period weighted moving average, you would be given 5 decimal values. Remember that regardless of how many decimal values you're given, in a weighted moving average forecast, the sum of the weights must equal 1. Now let's do an exponential smoothing forecast for year 6. So in this case, you will always be given alpha, and you will always be given the forecast for year 1. So alpha here is 0.3 that we would like to use. The forecast for year 1 is determined to be 15, and I've shown you here, this is the screenshot of the formulas that you would be given on a problem just like this. So this mirrors pretty closely what you might see on the exam. Now remember, with an exponential smoothing forecast, we're going to have to build up to get to a year 6 forecast. So we're just going to start in year 1. We have that forecast of 15. We're going to have to calculate a forecast for year 2 and year 3 and year 4 and year 5 to get to year 6. So because of that, what I might do is I might set up the problem similar to this, and I might go ahead and write down the years and write down the demand and write down my first year's forecast, which is 15. Now that gives me all of the variables that I'm going to need to continue calculating year 2, 3, 4, 5, and 6. So why don't you pause the video and you try to solve this one using the formula that's shown here. You solve for the forecast for year 6 using exponential smoothing, and then I will come back and I will show you how that math is done. Okay, because exponential smoothing is a forecasting method that builds up, in other words, it's dependent on all of the previous forecasts in order to make a forecast for the next period. It's very important when we're doing this math to recognize where it is that you are standing, or what is the current year. So in our case, the forecast for year 1 has already been given to us. The forecast was 15. Of course, like all forecasts, that forecast is wrong. The actual demand was 12. So we had some error involved there. So now we are standing in year 1, or the current year we're going to think of as year 1. The current demand is 12, and our most recent forecast was 15. And we are going to have to forecast into year 2. So from the formula on the right, ft plus 1, the current time is year 1, and so we are forecasting into year 2. So this is going to equal alpha, which is 0.3, multiplied by our current demand, 12, plus 1 minus alpha, 0.7, times our current forecast, or the forecast that was given previously for our current year. So that is 15. When we do that math, we find our forecast for year 2 to be 14.1. And again, that forecast is wrong. We forecast 14.1, but the actual demand is 16. So now we move to year 2. So now our current year is year 2. The current demand is 16, and the forecast for our current year is 14.1. We put those numbers into the equation, so 0.3 alpha times our current demand, 16, plus 1 minus alpha, 0.7, multiplied by our current year forecast, 14.1, gives us our next year's forecast, or the forecast for year 3. So now the forecast for year 3 is 14.67, and once again, just like all forecasts, this forecast is wrong. Our actual demand is 10. Next, we build up to the next year. Now our current year is year 3, and we are going to forecast for year 4. So we're going to take year three's numbers, in other words, years three demand and year three's forecast, and we're going to use those numbers in the formula to forecast for year four. So you can see the math here, 0.3 times 10 plus 0.7 times 14.67 gives us 13.27, and we go to the next year. Again, the same math follows. We are now standing in year four, or our current year is year four. We're forecasting into year five. And so here you can see the math, and we get a forecast for year five of 11.99. So we forecasted almost 12, 11.99. Our actual demand was 13, and now we need to forecast into year six. And so we're going to use that same math again. We're going to say the forecast for year six will equal alpha, 0.3, multiplied by our current demand, 13, plus 1 minus alpha, 0.7, multiplied by our forecast for our current year, which was 11.99, and that will give us our forecast for year six. And here we see that math. So our best guess, using exponential smoothing forecast for year six with alpha equals 0.3 and the forecast for year one determined to be 15, our best forecast for year six is 12.29. Now we will be given a linear demand forecast. Recall that for this class, for the purposes of this class, you will not have to derive the linear forecast. In other words, you will not have to create the linear equation given a set of data. So that is not something we're doing for this class. In this class, you will always be given the demand forecast equation, and you will simply be asked some questions about that equation. So let's take a look at this. So here, demand equals 37 plus 8x. X is the desired forecast period. Now, one question that might be asked on the exam would be, how much is the demand expected to grow every year? And so in this case, the amount that the demand is expected to grow is by 8. So the number there, the slope number in front of the x value, is how much is expected to grow. If that were a negative number, in other words, if the equation were 37 minus 8x, then that would be a situation where the demand was expected to decline, and it would be expected to decline by 8 units each year. But in this case, with these linear demand forecasts, then the demand is expected to move at a constant rate over time. And in this case, every year it's going to increase by 8 units. So all we need now is to know which period we are going to be forecasting into to determine what the demand is for that particular period. So here it's asking, what is the predicted forecast at period 9? Let me give you a few minutes to solve this problem. To solve this, all we do is enter the period that we are interested in into our equation. So in this case, it's 9. So our demand forecast is 37 plus 8 times 9, or 37 plus 72. This gives us a forecasted demand of 109 in period 9. And then you can see that then in period 10, and you can test this out on your own, the demand is expected to grow by another 8 units. So if we have 109 in year 9, then in year 10, we should have a demand of 117. And of course, you can check that out on your own as well. All right, let's take a look at some problems dealing with measuring forecast error. So let me give you a little bit of a review of forecast error. If you'll recall, every forecast will likely be wrong. And that's just one of the part of the nature of forecasts. And as you've just seen, there are many different forecasting methods, and the ones that we're doing for this class aren't even all of the different forecasting methods available. There are dozens of different forecasting methods that are used in a variety of different scenarios. So the question is, well, how do you know which forecasting method to use? The way that you know is that typically in a real business setting, you would test several different forecasting methods on a set of data, and then you would measure the error that is involved in using any one of those particular forecasts. There are some companies that prefer one particular type of error measurement. Some companies will take a look at several of these different error measures to figure out which one of their forecasts is the best. In general, the best forecast will be where the error measures are as close to zero as possible. Remember, errors can either be positive or negative, and several of these different error measurements can result in either positive or negative numbers. And companies would prefer if their error was as close to zero as possible. So we can identify a forecast as being biased if in general it tends to either over forecast or under forecast for a set of data. So let me explain. You see the error measurement or the error formula at the top of the formula page. Forecast error equals demand minus the forecast. Now, when we tend to over forecast, when we forecast more than what is demanded on a regular basis, then we'll end up with a negatively biased forecast. In other words, these error numbers will tend to be negative numbers because the demands will tend to be smaller than the forecast numbers. When we have a negatively biased forecast, then we will end up with excess inventory. The inverse is also true. So if we have a forecasting method that tends to under forecast, in other words, it tends to forecast too low, then mostly we'll have demands that are greater than our forecast. So most of our error numbers will be positive numbers. This is called a positive bias forecast. And with a positive bias forecast, we typically won't have enough stock to take care of the demand. So we'll have stockouts. In other words, we're going to run out of material. So in general, we would like those numbers to be zero. Now, when it comes to the tracking signal, the same thing is true. We would like the tracking signal to be zero, but it's going to fluctuate up and down. And the tracking signal gives us a sense for when our forecasting method is out of whack. So with the tracking signal, the rule that we're using for this class is that if we have a tracking signal that is between -4 and +4, then we are going to assume that the forecast model is performing normally. But otherwise, if it's outside of that range, so if we have a tracking signal of -4.3 or a +5.2, if we have a tracking signal that goes greater than 4 or less than -4, then we are going to assume that something's probably wrong with our forecasting model and we should take a look at it. So in this case, just like on the exam, you'll be given some data just like this, and then you will be asked to calculate the error in that forecast using one of these particular methods, and then you'll use the formula. I'm going to find it easiest to solve these problems if you copy down or somehow write down the data and then write down additional columns of data where you can do sequential calculations, because these problems are going to require you to do several calculations in a row. So for you, I would like for you to think about this first example. What is the running sum of forecast errors? So we're going to use that formula for RSFE. And I want you to take a look at the data, see if you can set up a table that we might be able to use to calculate the running sum of forecast errors. Why don't you pause the video and give this a try yourself? Here's how I would set it up. I would put a column for error. Error is the same thing as forecast error, and because I'm going to have to do that for every year that's shown here. And then, of course, this is the running sum of forecast errors. And so to find the running sum, well, I'll let you give that a try. How about that? So pause the video again, and then you see if you can fill this in and get the running sum of forecast errors. All right, here's what you should have found. we're going to calculate the error. And remember, the errors can be positive or negative. So when you calculate forecast error, use the formula that's shown here. It's going to be the demand minus the forecast. So you can see here in year 1, 12 minus 15 is negative 3. 16 minus 14.1 is 1.9, and so forth. We then take the sum of those errors. That sum there in year 6 is the running sum of forecast errors for all of the data that we have. All right, let's do another example. And again, these are set up very similar to how you're going to see them on the exam. In other words, there will be a question asked about one specific type of error. You'll be given a set of data, and then you'll also be given the formulas that relate to that. So in this case, we're asking for the mean forecast error, or MFE. So why don't you see if you can set up the table and solve this problem? Here's how the table would be set up again. And here's the solution. We have to find the forecast error for each of the years. We add them all up and then divide by the number of years that we have. That's how the formula is written. It is simply the average of all of the forecast errors. And this mean forecast error can either be a positive number or a negative number. In this case, it's a negative number, so we know we have a negatively biased forecast. Here's the next one. Why don't you read through this problem example and see if you can set up the table that's needed to do the calculation. Go ahead and pause the video while you put this one together. Here's the table that you're going to need. For mean squared error, you're going to need the forecast error, and then you're going to need to square that forecast error. Of course, if you can do that in one step on your calculator, you could just have a column there for squared error. But I'm going to show it here in 2 steps where I show the error and then I'm going to square it after that. All right, pause the video again and you solve this one. Okay, in this case, the error numbers can be positive or negative, but then when we square them, notice that they all turn positive, because when you take a negative number and multiply it by itself, it's going to turn into a positive number. And all we're asking for in the mean squared error is the average of all of those squared errors. So to get that, add them all up. It equals 53.67. And then divide by the number of years that we have. So divide by 5. It gives us a mean squared error of 10.73. All right, here's our next example. Go ahead and pause the video, read the problem statement, and see if you can set up the matrix that is needed, the table that is needed to be able to solve this one. Here's what yours should look like. In this, for the mean absolute error, all we need is the absolute error. So that's the column that I've placed here. Go ahead and solve this problem. Remember, the absolute error is just the error, except that we have taken the absolute value of all of those numbers. So there are no positives and there are no negatives. And we just, to find the mean absolute deviation or the mean absolute error, we are going to add all those up. It equals 14.85. Divide by 5, and we end up with the mean absolute deviation. All right, here's the next one. the mean absolute percentage error. See if you can set up the table for this problem. For most of you, for this problem, you're actually going to need two columns. One to calculate the absolute error, and the next one to calculate the percentage absolute error. And the percentage absolute error is listed there in the formula. It is the forecast error, or the absolute value of the forecast error, divided by the demand. So here is the solution. The absolute percentage errors are given here. They're all given here in decimal format. You will add them up and then divide by the number of years that we have. So again, dividing by 5, and we find that the mean absolute percentage error is 0.2776, or 27.76%. And for our last example, we will be calculating the tracking signal in year 5. So for this problem, the tracking signal is the running sum of forecast errors divided by the mean absolute deviation. So we're going to need to find the errors so that we can find the running sum of forecast errors. And we're going to have to calculate the absolute error, which is the mean absolute deviation. So that's why I've set up these two columns here. I'll give you a chance to try to work through this one. Of course, we have calculated the running sum of forecast errors and the mean absolute deviation on previous slides, and now all we have to do is take those two numbers and divide them. Notice that in this case, the running sum of forecast errors was a negative number, so our tracking signal is negative. The follow-up question for a problem similar to this would be, is there something wrong with this forecast? And the tracking signal here is between -4 and +4, and so by the rules that we're using in this class, then this indicates that this forecasting method is operating normally for right now. So those are samples of all of the math type questions that are going to be on the exam. And you can find more examples of those in the practice problems section of Blackboard. I'm going to strongly encourage you to look over the exam review sheet, which will list every topic that is going to be covered on the exam. And as a reminder, all of those topics were covered during class in using the PowerPoint slides by your instructor. And as a final reminder, the Blackboard content will be removed as soon as the exam begins. Additionally, assistants and instructors will not be available while the exam is going on to provide equity for all of the students taking the exam. So make sure that you download any content off of Blackboard that you would like to have to study, and make sure that you get your questions answered by the instructional assistants or by your instructor prior to the beginning of the exam testing sessions. Best of luck on the exam.